Okay, so the law of sines, the law of sines is the ratio between a side and the sine of the angle opposite of it is equal to another side of the triangle and the sine opposite of it, which is also equal to the ratio of the third side and the sine of the angle opposite of that side. So it's A over the sine of A, B over the sine of B, C over the sine of C. Now you could flip all of those and you could say the sine of A over A equals the sine of B over B equals the sine of C over C. Now this could be done. The reason for the law of sines and the law of cosines is because you don't have a right triangle. And the trig functions of sine, cosine, tangent are only used if you have right triangles. But if I talk about a right triangle, and if I talk about a 30, 60, 90 triangle, I could still use the law of sines. So we know that they're in the ratio of 1, 1, radical 2. So I don't care. Let's just pick a value. Let's just say I had this right triangle right here. Oh, that's not 30, 60. Darn it. But I want 1, 1, radical 2. So we'll go back to a 45, 45, 90 triangle. So that's in the ratio of 1, 1, radical 2. So if I had a 45-degree angle and I knew that this side was 5, and then I was looking for what is the value of that hypotenuse, for an example. You could use the law of sines to find that, even though I've shown you what the hand trick is. So if I were to use, well, first of all, let's go to it. We know that this x value has to be 5 radical 2. Using the law of sines, we look for the pair that you know, the side and the angle opposite of it. So it's going to be 5 over the sine of 45 is equal to, and then look for that other pair. So you're looking for x, and the angle opposite of it is 90 degrees. So we're going to say x over the sine of 90 degrees. Now I'm guessing this might be I don't know what examples you're going to have where you can't use a calculator. But if I were to calculate this and continue calculating it, I'm going to go to the next step, and it's going to be 5 over the sine of 45. The sine of 45 degrees, if you fold in your 45-degree finger, which is your middle finger, the sine is going to be radical 2 over 2. Now that's equal to x times the sine of 90 degrees. So if you want to know what the sine of 90 degrees is, you can think of that unit circle, and you can remember that you're talking cosine sine. So you're talking about the y value of 90 degrees. And right up here is going to be 90 degrees in a unit circle. That radius is 1. So that coordinate point is going to be 0, 1. So the sine of 90 degrees has a value of 1. Now you could do the hand trick for that as well. Let's come clear over here to the right and look at your hand trick. So it's cosine, comma, sine, where the finger you bend down over 2, where the finger you bend down is your comma. So 90 degrees, you're going to be folding in your thumb. So the cosine, you don't have anything over here for fingers. Radicals for the sine value, you're going to have 4, so you have the square root of 4 over that 2 that's in your palm of your hand. The square root of 4 is 2, so you get 2 over 2, which is 1. So if you solve this, if you're going to solve that, you need to cross multiply and divide. So now I'm going to take this value right here. I'm going to move it over here so I have room to calculate that. So you're going to take 5 times 1, and you're going to divide by radical 2 over 2. Now that's a keep, change, flip. So it's times 2 over radical 2. And that gives you 10 over radical 2. If you rationalize that denominator, you're going to end up with 10 radical 2 over 2, but then 2 goes into 10 5 times, and you get 5 radical 2. The same thing you can get from a previous video that I sent you that deals with this special triangle right here. If this side is 5, and this is 5, then I know that this is 5 radical 2. So I know that that would have a value of 5 radical 2, but you could, like I mentioned, solve it by using sine, cosine, or the law of sines, sorry, is how you could also solve it. If I look at this particular example that they have given to me, and I want to solve, I'm going to look for the pair, which the pair is going to be 19 and the angle measure of 137. You have to have a pair. If you don't have a pair, then you need to resort to the law of cosines. So I have a pair here. I have 19 over the sine of 137, and that's equal to the other pair that they are looking for, or what they want is q. So it's a side length of q over the sine of 17. So to solve, you're going to cross multiply. Take 19 times the sine of 17 and divide by the sine of 137. So they want my answer as an integer or a decimal, rounded to the nearest tenth. So if you were to take your calculator, I've got to find my calculator here, just a second. Okay, so you take your calculator, and if you were to go ahead and calculate that, oh, I'm deleting a whole bunch of things on my calculator to get to it here. Okay, so 19 times the sine of 17, and then divide by the sine of 137. 137, it showed up as 17. Good thing I double checked that. You get a value of 8.14. So that's just going to be 8.1. Now, if you look at it, it's got to be smaller than 19, because if you look at 137 and you look at 17 degrees, 17 is a lot smaller than 137. Also, if you look at it, R would have a value of 26 degrees. So Q has to be the smallest side length in that particular triangle. And it is when we calculate it. Now, hopefully, we'll get this, 8.1. And there you have it. So let's look at one more example, even though I can't set this up. Like I said, without your calculator, I don't know how they expect you to know what is the sine of 137 degrees. So I don't know what type of problems you're going to be dealing with this, which is making it hard for me to try to come up with some examples for you. So if I look at this one, first thing you ask yourself to help you determine, are you going to use the law of sines or are you going to use the law of cosines? Look and see if you have a pair. 19 degrees and 8. I have a pair. I have E and angle E, and I have angle F and side F. So your ratios that you would set up in the law of sines, since you do have a pair, you have 8 and the sine of 19 is equal to, come up with another ratio, which is going to be E, the sine of E, which you could find angle E by just the sum of the angles of a triangle equal 180. And then you're going to have, that's 14 degrees, not the side length. So then you're going to have F over the sine of 14. Now, like I mentioned, if you take 180 degrees and you subtract that sum of 19 and 14 from it, you're going to find out that the sine of E, I could change, and I could change it to the sine of 147. So looking at it, your longest side should be E, which is obvious in your triangle. Now let me get rid of this mess here. So we can see that side E would be the longest in my triangle. And I know that F, since 14 degrees is smaller than 19 degrees, F should be smaller than 8. So if I calculate it, we do want to find F. So I'm not going to worry about this one for right now. So I'm just going to look at the blue and the red. So I'm going to cross multiply 8 times the sine of 14, and I'm going to divide, which is the sine of 19. So if I calculate that, 8 times the sine of 14, and I divide by the sine of 19, I get an answer of 5.9446. We want it rounded to the nearest tenth. So that's just going to have a value of 5.9. Oh, and I need to type it in the right spot. 5.9. Okay, here's one where you have that 30 degrees instead of typing in the sign of 30, but you're going to have to involve the sign of 83, and then you run into troubles because you may not know what the sign of 83 is. So that's where I said I'm not quite for sure how they want you to do this without a calculator. So the first thing, do you have a pair? Yes, I have a pair. So it's going to be 12 over the sine of 83 degrees. They want me to find t, so I'm going to look at t and the side opposite of that. So I'm going to have t over the sine of 30. Now, like I said, if you had your calculator from here, you would just be cross multiply 12 times the sine of 30, and you're going to divide by the sine of 83. You know the sine of 30 degrees, if you fold in 30 degrees, which is your ring finger, you're going to find out that the sine of 30 degrees is 1/2 divided by the sine of 83. So without your calculator, that's the way that I know how you would do it. Like I said, I'm not quite for sure your application of this when you don't get a calculator. So it's 6.045, which is just going to be 6.0 in this particular case, because they asked me to round to the nearest tenth. So I need to make sure that I think I put that 0 there. Otherwise, I have a feeling that iExcel here might take it incorrectly. So this is going to give you 6.0. Hopefully here I can find one where they're going to ask you. I'm going to do a few of these if you think you have it right now. If not, shoot me a message telling me that you need a few more examples. If not, what I'm going to do is I'm going to look for one where they're asking you to find the angle measure. So I'm going to pause it until I find one. Okay, here's another one. Not quite the one that I was thinking of, but once again, if you look for pairs, so you have 8 and an unknown angle measure. So it's 8 over, whoops, the sine of x, that's x degrees there. So you have 8 over the sine of x, and then you have z over the sine of 66 is equal to y over the sine of 79. Now, as you look at that, after you've set up your pairs, and I said, well, you have to know a pair in order to use the law of sines, and you're like, oh, I can't use the law of sines, I got to use the law of cosines. Because if I focus on calculating any two ratios, if I calculate these two, I have an x and y involved. If I calculate the first and the third, I have variables of x and y. And if I calculate the last two, I have variables of z and y. So we know that if you have two unknown values, it takes at least 2 equations to solve. Well, right now I have 3 different proportions, but none of them line up to where it's going to be too beneficial for you. So the first thing you have to do is you're going to have to take that 180 degrees and subtract the other 2 angle measures from it, or the sum of those, to figure out that angle x is going to be a 35-degree angle. So then you can come back up here and you can replace that sine of x. So you're going to have 8 over the sine of 35 degrees. What they are asking you to solve for is z. So you do have your proportion right here that you can solve. So you're going to take 8 times the sine of 66, and you're going to divide by the sine of 35 degrees. And when you do that, you get 12.741. So it's just going to be 12.7 for an answer. So here's another one that's set up that same way. You really don't know a pair because 14 opposite of that is an unknown angle measure known as x. But if I do take 180 and I subtract the sum of 38 and 94, or just subtract both values, whichever way you want to get there, you're going to find out this is a 48-degree angle. So you would have 14 over the sine of 48 degrees. What they want to know is W. So you were dealing with the 94-degree angle. So it's going to be the side over the sine of 94 degrees. So take 14 times the sine of 94 and divide by the sine of 48. And you're going to end up with 18.79, which is going to make it 18.8. So I get 18.8. So I'm going to go through a couple more of these examples and see if I can't use it to where I need to find the law, use the law of sines to find the angle measure. Okay, so I can't find an example of what I was looking for, but I did want to show you what happens if they're looking for the angle measure. So this one you're probably recognizing is a 30-90-60 or a 30-60-90 triangle. But if this was the information that I gave you and I was asking for angle X, you would go ahead and you would get your pairs. So I have that pair there. So if I look at it, I don't like my fat writing utensil that you get. So if you look at that, what you're going to get is your pair. So you're going to have 5 over the sine of 30 degrees is equal to 5 radical 3 over x, the sine of x, not just x. It's the sine of that particular angle, so it's the sine of x. So if I cross multiply and divide, you're going to say that the sine of x is equal to what you get when you cross multiply and divide those those 3 remaining values. So you're going to get, once again, I want my small line here. So you're going to cross multiply, and then you're going to divide by that 5, and that's what sine of x, or that box, is going to be in your proportion. So the sine of x is equal to 5 radical 3 times the sine of 30 divided by 5. If you look at that, we know that these are going to cancel. So we could work with that if you wanted to. You talk about what the sine of 30 degrees is. So that's going to have a value of 1/2. So then you're left with radical 3. Because the sine of 30 degrees, remember, you're going to put your ring finger down, and it's cosine sine. So you get this for a value. And if you multiply those together, you are going to end up with radical 3 over 2. Now keep in mind, that's what this bottom box is in your proportion. So it's saying the sine of x is equal to radical 3 over 2, which is the same thing as the inverse sine of radical 3 over 2. What I wanted to point out is that if you're looking for the angle measure, you are going to have to do the inverse. So you can't just stop with radical 3 over 2. So the sine, the angle measure that has a sine of radical 3 over 2, you're going to be thinking of your hands here. This is really bad hand there. But you want the sine of radical 3 over 2. So you're going to fold in your pointer finger, which is 60 degrees. So x would have a value of 60 degrees. And that is what it would be if you know your special triangle of 30, 60, 90. But anyway, once again, I'm not quite for sure how these questions are being asked to you. I haven't seen any of your examples or problems you've had to work through, but you can use the law of sines with a right triangle. And to do that, I just am using that concept of what you already know about your trig functions and a right triangle to go ahead and solve it so you can apply it to triangles that are not right triangles. I hope this helps. If you have more specific examples, please let me know. Shoot me a text so I can get you another video sent.